my name is Justin Chaffin. I'm the research coordinator at Ohio State University Stone Lab. We are located on South Bass Island in Lake Erie. My job title is a research coordinator, and I specialize in harmful algal blooms in Lake Erie, and now we're doing some projects in inland lakes. The harmful algal blooms are a type of algae that can produce toxins, and my projects focus on what causes the blooms to grow and what causes them to produce toxins, and we're using that information to alert water treatment plants that pull in water that need to remove the algae and remove the toxins so they can produce safe drinking water. How we do this, we do a combination of field sampling. So we're out here on the research vessel today. We'll grab samples from the lake and process them and get data that way. We also do experiments where we'll get water from the lake that has algae, take it to the lab, incubate it with extra phosphorus or extra nitrogen at different temperatures, and see how the harmful algal blooms respond in terms of growth and toxin production. There's two ways we get data from the lake. One is through deployed instruments. So you see a buoy behind us. That buoy has a water quality sensor that is constantly taking water temperature, water pH, turbidity, the amount of oxygen, and also the amount of algae and amount of harmful algal blooms. That is constantly recording data. The data gets beamed to the internet, and anyone can download in real time. We also grab water samples, which we'll demonstrate here next, where we'll grab water sample, process it, and take it to the lab and get more detailed data, such as how many, what type of algae are present, are there toxins present, what are the nutrients that are in the water, how much sediments are in the water. So we're going to demonstrate that now. One way we collect water from the lake is using a device called an integrated tube sampler. This will give us a sample from the surface down to 2 meters. And it gives a good representation of what's happening at the surface. We simply don't want to throw a bucket over the water, over the edge, and scoop up surface water, because it might be a little biased. If it's calm, you might have a lot of algae floating at the surface. If it's rough, that algae might be mixed further down. So we want to get a nice slice of the entire water column. How this works, we're going to lower it into the lake, nice and slowly. Then I'm going to cap it, and this is analogous to like putting your a straw in a glass of water, putting your finger on the straw and pulling it out. The water remains in the straw. Water is going to remain in the sampler, slowly pours out. So now we're going to test the water sample for microcystins, which are the main toxins that the cyanobacteria produce. This project, or this device we're working on, is a new instrument that will allow us to get toxin data in 20 minutes. The normal method of analyzing for microcystins takes about 4 to 5 hours, whereas this will give us data in about 10 minutes. So the first step is to lyse the samples, or to break open the cells. One of our projects that we're working on is testing a rapid microcystin test. The normal microcystin test takes 4 to 5 hours and has to be done in the lab. So we're working with this company based in Boulder, Colorado, that's developing a rapid test that'll get data within 20 minutes. So the first step of the method is to break open the cells, which we did. It takes 10 minutes. And then next we are going to put 100 microliters of the sample onto a cartridge here. This cartridge has all the same chemicals that the standard lab test has. So the next step is to add the lice sample to the reagents, which you see Autumn here doing now, pipetting the water and the reagents together. And then once that's mixed, she will add it to the cartridge. So she's adding the sample to the cartridge, and then she will pop it into a reader, which then takes 10 minutes. All right, now the sample will take 10 minutes. A couple of the research projects that we're working on are funded by NOAA through their EcoHab program and their MIRHab program. The MIRHab program is the one that I talked about using the rapid microsystem tester. We're doing that to get a lot of data. So we need a lot of data in the lake to populate our models which is the second project that we're working on, is funded by the EcoHab program, where we're taking all the data from the lake, putting it into a model, and trying to forecast harmful algal bloom toxins several days in advance. So water treatment plants, beach managers, general tourists have an early warning or an early idea of how many toxins will be in the lake at that given time. The test is finished. The microcystin concentration was 0.8 micrograms per liter. That's pretty typical for this time in Lake Erie in the Western Basin in late August. We've seen much higher. The swimming advisory is 6 micrograms per liter. So the water here is still perfectly fine to swim in, fine to fish. This also, what I didn't mention earlier, this test also does a second toxin called selendospermopsin, which we do not see very often in Lake Erie or in the state of Ohio. But this instrument does have the potential to do, or it does do 2 toxins at once. Just for our purposes, we're only concerned about microcystins because we will never see, or hopefully we'll never see, selendospermopsins. So then what we would do, we would take that sample we collected, take to the lab, and do the gold standard ELISA test, so we can compare 0.8 from the end bio unit to what we would get in the lab.